Now, we will see the difference before and after installing the automatic control device for automotive fuel supply and how it works with the engine. We chose a 4500cc sedan as our test vehicle with the state-of-the-art electronic control unit, or ECU. The reason we chose this luxury sedan as a test vehicle is to disprove the prejudice that many people have against cars with larger engines. Won't have a problem in fuel supply compared to small to mid-sized cars. For the convenience of the test, we installed an on-off conversion switch to compare the result in real time, before and after the installation of the device. We also installed a digital gauge that could measure the pressure directly related to fuel consumption. Note that as the number on the digital gauge goes up, the amount of fuel supplied goes up, and as the number goes down, the fuel supplied goes down. First, we'll start the engine without the automatic control device. While the engine is currently running and the vehicle is not moving, the fuel pressure gauge shows 3.1 to 3.2 kilograms of force per square centimeter. This is the standard fuel supply pressure level automotive manufacturers have set on purpose. Now, after turning on the switch, let's look at the pressure intake level after installing the automatic control device. After changing to this device, the pressure level of supplying the fuel to the engine now indicates 2.5 kilograms of force per square centimeter on the gauge. Comparing the pressure level difference before and after installing the device is remarkably large, which is 0.6. This means without the device, this is 0.6 difference in pressure or more than 15% of the unnecessary fuel pressure is forcefully supplied to the engine. Now, we will check the changes in fuel pressure before and after installing the device under actual driving conditions. First, we will check the fuel pressure supplied to the engine while driving without the device. Although both the RPM and speed are now increasing by pressing on the accelerator, the pressure level is the same as when the vehicle was not in motion. This constant pressure of 3.2 is what manufacturers have set on purpose. Now, even though the car is in motion, I will take my foot off the accelerator. As I take my foot off the accelerator, RPM and speed go down, but the fuel pressure supplied to the engine remains constant at 3.2, just like when the car was not in motion. Now, after turning on the switch to start the automatic control function, we will see how the fuel pressure changes as we drive the same way as before installing the device. As we turn on the automatic control function, you can easily confirm the fuel pressure is being controlled even under the same driving condition as when the device was not installed. Next, I will take my foot off the accelerator while driving, just like I did before using this automatic control device. As I take my foot off the accelerator, both RPM and speed go down. Fuel pressure supplied to the engine also begins to change. When you look at it, you might think that the reduced fuel pressure by installing the device also reduces the output of the engine. For that reason, we will turn on and off the automatic control device while maintaining a speed of 100 kilometers per hour and see how the fuel pressure level changes. First of all, by stepping down on the accelerator to maintain a speed of 100 kilometers per hour, the gauge shows 3.2 on the pressure gauge without the automatic control device. Now I will turn on the automatic control device while maintaining the same speed. As the automatic control function kicks in, the fuel pressure the engine inhales went down to 1.8 while maintaining speed. Again, as soon as we switch off the automatic control device, the pressure goes back up to 3.2. And when we switch back to the device, fuel pressure lowers to 1.7. The pressure changed to around 1.7 to 1.8. This proves that the device automatically controls the fuel pressure even with minute changes to driving conditions. This concludes our test.